Well, hope you guys are doing well today. Good afternoon to you. Those of you who are distant today, what we are going through on these notes and assignment are going to be what you're going to be applying in class on Thursday. And our topic that we're going to be talking about right now is applying what's called dimensional analysis. Okay, and so basically what I'm trying to do is change one type of unit into another type of unit. And we have to do that quite a bit, especially starting in this unit where we're talking about motion, because we can measure motion in inches per day, meters per second, kilometers per hour, and it's nice for us to be able to recognize that some units are the same as other units. And this is actually one of the more useful skills you can learn actually through all your schooling. If you go to a grocery store and you see that something costs $2 for 8 ounces and then you see it costs $3 for 14 ounces, what's the better deal? So you've got to make some conversions between these, or like so many pounds is worth X amount. So this is a valuable skill. What I'd ask you to do is open up the assignment today. It's called Science Math Skills. Open it up on Google Classroom, and if you could, I would ask that you take a photo on your phone as I work through, if you could. That way you kind of have a reference point to see what I'm talking about. You don't necessarily have to take notes, but you might want to write down, I would write down the answers as I go through just to show you how it's done here. Okay, so just kind of think about it. If you need to pause and print that up, if you could print it, that's ideal. If not, then just try to work through on the Google document as I go through. You could pause the tape and then enter in your answers. That might work as well as you go through, because these example problems are actually on the first page of the assignment. So if you need to kind of open it up and find it, I would recommend doing that now and having a tab open for that, and then just kind of work through and enter in the answers as I go through on this demonstration, because then you can refer back to them as you apply them. So the reason why dimensional analysis works is because we know that some units are exactly the same as other units. If I count out 12 donuts, that's exactly equal to 1 dozen donuts. There's no difference between the two. I could place an order and say, hey, I want 12 donuts, or say, I want 12 donuts. It doesn't matter. It's exactly the same thing. So this is the whole basis behind why dimensional analysis works. If I have 1 dozen divided by 12, that's the same thing as 1, because they're exactly the same thing. It's the same as saying 3 divided by 3. It's the same number. 1 dozen is exactly the same as 12. Now, this might be stating the obvious, but anything multiplied by 1 is the same number. Okay, so you're going to see why this is important when we do dimensional analysis. So let's say I have not a dozen donuts or 12 donuts. I've got 36 donuts. How many dozen donuts do I have? And again, this is the first example problem on that tab, so you can just kind of fill it in as you go through here. So the way that you do this is you set up what's called dimensional analysis. You start with whatever your first unit is, and then you multiply it basically by 1. Okay? 1 dozen over 12 donuts is 1. If you multiply anything by 1, you're going to get the same number. But all we're trying to do is change units. So what we're going to do is we are always going to put the unit we're trying to get rid of on the opposite side of the fraction. So here I've got donuts basically in the numerator. I'm going to put donuts in the denominator. I could reverse this and say 12 donuts over 1 dozen. Exactly the same thing, but it's whatever I'm trying to get rid of, I'm going to put on the opposite side of the denominator. So here I've got 36 donuts, 12 donuts. A donut divided by a donut, those cross off. So I end up with 36 dozen because that's what I'm going to, divided by 12. All I did is I moved this numerator across and I moved this denominator across. The 36 divided by 12 is now 3 dozen donuts. Now a lot of you could have hot dogged that and said, well, I know that 36 divided by 12 is 3, but you're going to see that problems get a little bit more complicated. Okay, so now I've got a table that's 3.5 feet wide. How many inches wide is the table? I'm going to do the same thing. 3.5 feet is my starting point, and now I need some type of number that is the equivalent of 1? Well, I know that there are 12 inches in every single foot. Notice I'm trying to get rid of feet, so I put feet in the numerator here, feet in the denominator there. That will cancel each other out. So I end up with 3.5 times 12, and 3.5 times 12 is going to equal 42. There's your answer. 3.5 feet is the same as 42 inches. And I'm using dimensional analysis to do that. Now we're going to get a little bit more complicated. A cheetah can run at 60 miles per hour. How many feet per minute is this? Now I'm trying to switch two things at once, okay, which gets a little bit tougher. Oops, I got a little out of control there. So I'm starting with 60 miles per hour, and I want to get to feet per minute. So I actually have to run through a couple steps. I want to convert miles into feet, and I need to convert hours into minutes. So here, first thing I'm going to do, I want to get rid of miles. I want to get to feet. So I'm going to put miles and feet on the opposite side of the fraction sign. And there's 5,280 feet in a mile. That's great. We've got that. So now I've gotten miles taken care of, and I've gotten to feet, which is what I want, feet per minute. Now I've got to convert hours to minutes. So here, hours is in the denominator. If I want to get rid of it, I have to put it on the opposite side of the fraction. I need to put hours in the numerator. So 1 hour is 60 minutes. That's what I'm going to. So now 60 minutes is in the denominator. So now I end up with feet per minute, which is exactly what I'd be looking for. So if I take 60 times 5,280, I get a big number, but then I'm going to divide that by 60. Okay? And you're going to find out that that actually ends up being 5,280 feet per minute. This just happens to be a happy accident that the cheetah runs at 60, and there's 60 minutes in an hour. So there's 5,280 feet a minute that a cheetah could run. So those are what are called dimensional analysis problems, and they help us convert from one unit to the next. Now, before we go on and I release you for your assignment, a lot of people the other day on their assignment got a lot of these wrong, dealing with significant figures. Remember, your measurement cannot be any more precise than any of your calculation can't be any more precise than any of your measurements. Okay, and very few people got the significant figures on that assignment correct the other day. So let me just repeat how you do this. When I add up three measurements here, when I'm adding them up, my least significant one is this one right here. That one I only know to the ones place. So even when I add this up, I'm going to find out that I get 36.66. Okay, I can't call it that. That's a big no-no. That's not going to work because I only know this to the ones digit. So I have to round to the ones digit. 36.66 is going to round up. This is going to be 37. And do not forget, I need units. That's 37 centimeters. This is the right answer. I know it's hard to believe, but this is a very bad answer. You're lying about what you know. You only know this. So when adding or subtracting, you're limited by whatever digits place is your least significant one. In this case, even though 21 is my biggest number, I don't have tenths of centimeters, I don't have hundredths of centimeters, so I'm limited to the ones place here. What about if I'm multiplying or dividing? Okay, so here I've got 2.7 times 1.6 meters. A meter times a meter, I know my units are going to be meters squared. But if I actually punch into my calculator 2.7 times 1.6, I'm going to get an answer that says 4.32. I cannot say that. I do not know it that precisely because I only knew this to two digits. I only knew this to two digits. The best I can call this is 4.3 square meters because this only had two significant figures. This only had two. Therefore, my calculation can only have two significant figures. So I want you guys to give that another crack because you really suffered showing me significant figures last time. So your assignment that you're going to have is called Science Math Skills, and then you're going to submit that to me. But Science Math Skills, let's see, right here. So you'll see that these are the demonstration problems that I just did on the first page. I've given you this metric ladder in case you need that, but I'm giving you a few problems here, and I'm giving you a little bit of scaffolding here to help you solve it. Okay, those blanks you're going to probably need to fill in. And then I gave these two examples for how to do significant figures, and then I've got some significant figures problems here for you to solve. If you could, finish that, submit it to me on Google Classroom, and we will call it a day, and I'll talk to you again on Wednesday. If you have any questions, please don't hesitate to send me a chat, and I'm more than happy to help you out.